And I'll zoom in. And as I go through this, I'll kind of go over some of the concepts you'll see just as like a preview. So the first word, circumference, distance around the circle. So you've seen that word before. It just means like the distance around a circle. And then the equation for circumference is pi times diameter. And that equation is on the EOC reference sheet, which is nice. So when you look at this, you have circle and then C equals pi times diameter, or 2 pi r. Both of these equations are for the same thing. 2 times the radius would be diameter. So that's why there's two versions. Also, as you can see, there's a lot of letters here, and you might forget like what the letters mean. There's also this key over here. So C is circumference, R is radius, D is diameter. So if you ever forget what the the letters are, there's this key right here. Okay, so that's distance around a circle. Then arc length is the length of an arc. So arc would be like part of the circle. So if circumference is all the way around, arc length would just be the length of part of the circle. Radian, I crossed that out because it's no longer part of the geometry standard, so we don't have to worry about that. And then here's sector of a circle. So something we're going to do is find area of just a sector of the circle. So yeah, we'll find area of the whole circle, and then you can use that to find area just like part of the circle, which will come up in a lesson. Over here, it's kind of random, but population density comes up in this chapter. So population density is like how dense the population is in any given area, or people per square mile or square kilometer. So for example, if we're comparing the population density in Myakka versus New York City, Myakka would have people kind of like spread out and a lower population density, whereas New York City, like everybody kind of lives in a very condensed small area, and it's more like this. So it'd have like a higher population density. Okay, and then up here it says the center of a regular polygon. So polygon is a closed shape with straight sides, which I drew. Regular seems like a very like unimportant word, but it means that all the sides are congruent and all the angles are equal. So all the sides are equal in length, and if that happens, then all the angles are congruent as well. So this would be a regular polygon. And then it's actually asking about the center. So the center would be the center right here. The next word is radius of a regular polygon. So radius is the distance from the center to a vertex. So we're going to write that down. Distance from the center to any vertex. Vertex is a fancy word for corner. And then central angle. So from the center, a central angle would be if you drew an angle from the center like that. In this case, this angle would be 72 degrees. Central angle of a regular polygon. The reason why this is 72 degrees, if you take 360 degrees, which would be all the way around, divide it by, in this case, 5, because it has 5 sides and 5 corners, we get 72 degrees. So that central angle would actually repeat itself all over, and all of these would be 72 degrees if my hand drawing was perfect, of course, but they're all 72 degrees. Okay, so then moving over here to the practice page, I already got that down. We're going to move over here. Recording.